Titled Don't Use This Keynote. Today is Saturday, September 26th, and I'm James. So all of my talks start in just about the same way, that we're at PyTexas at Texas A&M. Y'all should already be quite familiar with what's going to happen now. So howdy, I'm James. This is the keynote, right? I mean, that's, if I were giving a normal talk or like a workshop or something rinky-dink like that, that might work. But let's go back. Let's try that again. Listen, you have all of these amazing organizers in this room who have put their blood, sweat, tears, and other bodily fluids into this event. And they're expecting to see your excitement. So we'll try that one more time. Howdy, I'm James. A little bit better. I have a very long and rambling keynote prepared for all of you. I'm trying to keep it slim on the introductions because I feel like people always introduce themselves at the beginning of a keynote, and then by the end you'll have forgotten anything I've said. But I do recognize a lot of familiar faces, and you may recognize me from previous PyTexas talks, such as my very first PyTexas appearance. This is the year I started giving talks in the Python community. I gave a talk in 2012 at PyTexas called Notable Features of Python. It was one of the best events that I attended that year, and I thought, 2013, I better come back. Well, it turns out in 2013, I was invited back, and I was invited back to give 5 talks. That may have been because I did a very good job in 2012, or it may also be because a lot of other speakers dropped out. They may or may not have dropped out knowing I was coming. They won't tell me. But it was a fantastic event. Last year, I came to PyTexas, and I gave 3 talks, and I thought it was a really good experience, and I really enjoyed it. This year, I forgot to submit a proposal, but I guess sometimes people just fail upwards. So instead of not actually being able to speak at all, I've been invited to Keynote, and I'm extremely flattered. This is one of my favorite regional conferences. I really like the organizers. I think the audience is amazing here. I love all of you guys. I'm originally from Texas. I grew up in Houston, Texas, so I'm really flattered to be here presenting this keynote. I do have an extra talk prepared. It is called Ridiculously Pointless Hacks in Python. If somebody drops out between now and the end of this event, maybe I'll have an opportunity to see it. Or alternatively, if you see me at lunch or in the hallway and you want to see just some ridiculous stuff, I'll show it to you. You'll get a sense for where this keynote's going pretty shortly. Bear in mind, hopefully I will also get a sense for where this keynote is going shortly. I'm not quite sure. So I've been to a lot of conferences, an enormous number of conferences. I think I've given, since 2012, I've given 50-something talks at 30-something conferences in like 9 or 10 countries. And so I've ended up seeing a lot of keynotes. And one thing that I thought was, if ever I'm the dope on stage, I want to make sure that my keynote has a couple of things. Number one, I have to show you code. I just feel like it's not a talk at a Python conference unless there's some code there. And boy, do I have some code for you. Also, I don't want it to be too dopey. I could have given there's keynotes about why Python is awesome, but it's 2015. We all know Python is awesome. Or I could talk about all sorts of things. And I want to really give you something that's interesting, that's not lame. And I'm serious about that. I'm really serious about that. And even though I may have only prepared some of the materials for this at 3 a.m. last night, I really have very seriously put a lot of thought into what I want to present. I had a lot of ideas. I'm going to try really hard to show you something that you might not have seen before and to present an idea or answer a question which you may have struggled with answering yourself in a non-lame fashion. I will tell you that one reason why keynotes come out the way they are is that there's very limited bandwidth. I have about an hour and only so many words to present some information to all of you. And bear in mind that I'm trying my hardest given the circumstances. So with that, I'll give you a very brief introduction of myself. I'll ignore all the other projects and all the places. If you want to talk to me, there's a couple of different ways you can talk to me. If you have money and you need Python, finance, data science, advising, consulting, training, or just connections in the Python, data science, or finance community, come talk to me. I will gladly take your money in exchange for those things. Otherwise, if you don't have money or you're not interested in those things, but you are interested in Python, please come talk to me, and I'll show you some neat things. One of my favorite things to do at a conference when I'm meeting somebody for the first time is I'll say, hey, you want to see something cool? And then I'll show something cool. So these are a couple of cool things I can show you. You can pick from this. They all have names that are intended to be provocative, but in a kind of nerdy programmer way. The latest one is Quarg, which is a kind of neat project I'm going to start working on. But if you want to, come up to me and talk to me, and I'll show you something you might not have seen before. But I would be remiss if I didn't mention at least one thing that I work on. If you have any exposure to scientific, numeric computing, or the data science community, you need to know about NumFocus. If you don't know about NumFocus, please come up to me and ask me, what's NumFocus? And I will tell you all about NumFocus. NumFocus is very important. In fact, it's so important that I have a NumFocus mention quota. I think I'm on 8 so far. The video folks can tell me on the instant replay, but I need to get at least 10 mentions of NumFocus in. NumFocus is really important. NumFocus is a 501c3 that supports data science in the Python, Julia, and R communities. It needs your support. It needs your contributions. It needs your participation. It's an amazing organization. A lot of you have already attended events like PyData in Dallas earlier this year that are hosted by NumFocus, and it's something that I'm very passionate about personally, among many things that I'm passionate about personally. So I'm going to start you off with something that might be considered provocative. And the reason it's provocative is I was told last night by the organizers, is this what you're going to do in your keynote tomorrow? Please don't. That's not going to work. So I said, well, I bet you I'll make it work. And one purpose of this keynote, and one recurrent theme in my life, is of some degree of anti-authoritarianism. Now, you might say, how can you be an anti-authoritarianist, considering that you are now the man? I mean, I'm on stage giving a keynote in front of all of you, so there is some dissonance there. But I was told I shouldn't do it, so of course, what am I going to do? I'm going to do it. In fact, in this specific example, and in all the other examples of stuff I can show you in Python, many of these were spurred on by somebody saying, you can't do that, or don't do that, or it's not possible to do that in Python, and me just feeling a need to fight back. So I'll show you what Did You Mean is. And it's a project that I came up with last year on a whim. It was a complete joke of a project, but something that ended up being a lot deeper than I thought it would be. So we'll start with some really simple Python code. There's almost nothing here. It's just a class, and it has a method called bar, and the method called bar doesn't do anything. We can create an instance of that class. We've done this a million times. You'll probably do it another million times before you go home tonight. Very simple. And you call bar, except you accidentally misspell it, and you get this nasty thing, attribute error. The foo instance has no attribute called Baz. Well, I have a module called Did You Mean? And if you're on Python 2, you can even pip install it. And after you install it, you type foo.baz, you just add to the bottom this little thing saying, maybe you meant bar. It'll try and figure out which one you actually meant. And you might look at this and say, boy, that's kind of useful. And you're wrong. It's not useful. It really is. Honestly, it really is not useful. Just learn the right methods. Don't use this. But the really neat thing is not that it does this, but how it does this. Sometimes they say it's not how well the dog talks, but the dog can talk at all. In this example, it's that this can be done at all. And I'll show you why. Your first question, or your first statement might be, that's kind of stupid, and you're completely right. But almost certainly some of you out there are saying, well, how do you do it? And I'm going to walk you through how I did it by walking you through how I didn't do it. So many of you in the audience might be new to Python, but you know that Python has exceptions. And you know that there's an exception called attribute error, and you can raise it like this. And you might raise attribute error and say something like, foo instance has no attribute Baz. And you might be smart, and you might say, I've read through the documentation on python.org, and I know that there's this module called sys. And in the sys module, there's a lot of neat things I can do to change the way that Python behaves. I can set line profilers, I can do all sorts of neat stuff. And there's this thing called sys.acceptHook. And when an exception is raised in Python, and nothing catches it, and it raises all the way up to the top level, sys.acceptHook is what catches it. If you happen to be using IPython Notebook or Project Jupyter has quite a few sys.accepthooks in order to print out these nice messages to the screen. In this example here, I create a very simple accept hook at the top level, and when I raise this attribute error, it triggers my accept hook. You might say, well, maybe that's how you did it. But if I did it that way, then if I had trapped the exception and not let it percolate up to the top level, you shouldn't see the maybe you meant message, but you do. So that's clearly not how I did it. Well, you might say, I know when you do the dotted access, in Python we have this terminology, and we call that attribute getting, or sometimes we call it getAttr. And I might know that if you do foo.bar, in Python it's more or less the exact same thing as saying getAttr foo bar. And this is one of the neat things about Python. This kind of dynamism is built into the language, and the distinction between the former and the latter is not as heavyweight as it might be in something like C or C++. And you might say, well, did you mean work with getAttr? And of course it works. And you might say, well, you know what? I know one of the neat things about Python is that it's a very dynamic language, and I can overload and I can override almost anything. I can override things in the built-ins. There's a getAttr function at the built-ins. I can write my own getAttr function, and I can override it. And here's an example of just that. I wrote my own getAttr function, and all it does is it prints out a little message when you call it. And you can see this is an example of calling it with did you mean disabled. And you can see it printed out the little message we had here and then triggered the normal getAttr code. And this is a really neat thing about Python. You're able to override pretty much anything. You can write your custom. You can override things all the way deep into the language like getAttr or setAttr. Should you? Probably not. There's almost no reason why you'd ever want to do this. But the language makes itself amenable to that kind of manipulation. Except that's not how I did it. Because if I had done it that way, then you'd see that the ID of the getAttr function would change before and after importing did you mean. And it doesn't. So I didn't change the getAttr function at all. The getAttr function that you have before you import did you mean and the getAttr function that you have after you import did you mean are exactly the same. You can tell because they have the same IDs. In fact, one thing that we know about Python is that the semantics of Python are passed by name. And so we can always capture references to things just with g equals getAttr. And we know that if I had gone in, I wouldn't have been able to affect any references that you've already captured. So this wouldn't work. So clearly there was no patching of the built-in getAttr. Or at least that wasn't how it was done, because otherwise this example here wouldn't work. You might say, well, one thing that I really like about Python is that it has a very powerful but very simple object model. Compared to C++, where we have the ability to override all these different operators, but the interactions between overriding different operators and templates and all of these advanced features can sometimes be a little hinky. In Python, I have this very simple object model where I have all these underscore functions. And the underscore functions are even guessable. If I want to override what happens when you call something, I write a underscore call. If I want to override what happens when you do an item lookup with square brackets, I override getItem. If I want to override the getAttr, the dot lookup, I just write a underscore getAttr function. So we know this exists, and here we have a very simple class. And when you try and get an attribute on that class, it triggers this custom code. And it prints out this message. And you can see this at play here. If I do .baz, this is without did you mean enabled. And you can see it prints out my little message there. So this is an example of something you can do. And it's one of the really simple things about Python. You have these objects, and you can add custom behavior to them very easily. And you don't have to worry about all of the strange interactions between different features that we had to worry about in C++. And if any of you remember, one of the reasons that the originators of the Java language did not include operator overloading in Java was, I think, because they were scarred by how poorly it was implemented in C++. Yet with Python, it's a very common thing to do. We do it all the time. And it's one of the very powerful features of the language. Except if I'd done it that way, did you mean wouldn't work on an old-style class. In fact, if I'd done it that way, did you mean wouldn't work on a built-in object. How on earth do I override getAttr on object itself? This is an object that's built into the language. It's written in C. So you might say, there's something else going on here. Now, if you're clever, you'll import did you mean, and you'll look at this method on did you mean, underscore file underscore. And you might say, this is another thing I love about Python. It's very introspective. It's very reflective. It's a live language. It has a rich runtime. And the rich runtime means that I can look at these objects like modules and figure out where they come from. And if you're even clever, you might say, well, in fact, there's a module called inspect that will tell me where the file is for a module. So if I'm running some code on my system that I imported from somewhere, I know exactly where it came from because the inspect module has a function called getFile that will tell me where it came from. And this is something that a lot of people love about Python because it makes debugging really easy. One question I love to ask C programmers, and I'm a C programmer myself, and I enjoy writing C, but if you're deep in a multi-thousand-line C file and you see a function, how do you figure out where that function was defined? Well, you have to look in every single header file, and every header file that header file includes, or you have to use something like exuberant C tags or cscope or something like that. Whereas in Python, you can always figure out where a function came from because you'll either see a def, a class, an import, or some name binding. And if you can't, you just run your Python code in your interactive console, and you use the inspect module to figure out where that code came from. This is one thing that people really love about Python. It's interactive, and you can interrogate the language in these very useful ways to debug. Now, when you do this on Did You Mean, you'll see that where this came from was a .so file. And that might give you a little hint, .so. It's not a .py file. So he probably must have written something kind of funny here. He didn't write it in Python code. He didn't implement this in Python code. He implemented it in C code. And if you've been around the block, you might say, well, you know, this is not actually that unusual. There's a lot of modules in the Python standard library that are written in C. One of the ones that one of my favorites, and one that I hope that all of you use, is called itertools. And if you look at what file that comes from, you can see it comes from itertools.so. Itertools is a collection of tools for manipulating iterables, and they wanted them to be very efficient, so they decided to write them in C instead of writing them in Python. And it's not that uncommon at all. In fact, there are quite a few modules that you might frequently use that are written in C. But being written in C doesn't seem to mean that much. I mean, there are modules in the standard library that are written in C and some written in Python, so there's got to be a little bit more here. You could look a little bit deeper and you could say, well, this .so file, if you weren't sure where the SO file came from, you could see what it was, and you could see that it was actually a C executable. And you might do the same thing on your Python executable and say, well, there might be something going on here, but this is the case with all shared objects in Python, right? So there's nothing that you've discovered here that's too interesting. Now, if you've seen any of my previous talks, especially if you've seen the talks about how I got into kind of core Python, into hacking Python the interpreter, one thing that you might remember is the dis module. And the dis module is how I got started really getting deep into Python. And what I did was I imported from the dis module a function called dis, and what that does is it disassembles some Python code. It tells you what the Python interpreter sees, not what the human sees. It tells you the bytecode that the Python interpreter uses. And I can run that on a little piece of code here that just calls foo.bar. And when I do that, I can see, well, this load global, I don't know what that is, and pop top, no clue. Load const none return value, that probably means return none. But there's this thing called load adder here, this bytecode called load adder. And if you're like me, you'll do exactly what I did when I was trying to figure out how Python worked under the covers, which is grep for load adder. And if you grep for load adder in the Python source code, which you can download from python.org right now, you'll find a little snippet that looks like this. And you'll see that Python interpreter is written very simply. It's very straightforward. It's just some very plain C code that's available for all of you to read. That's actually very easy to read if you have any experience writing even Python. And you can see that when you do a load adder, when you do a dotted lookup, what it does is it calls this other function, PyObjectGetAdder. If you spend a little bit more time in the pieces of code above and below, you'll see that there's this very nice correspondence. Every time you have some behavior in Python, like loading an attribute, or loading an item doing your square bracket dictionary lookup, or calling a function, there's usually a corresponding bytecode, load adder or call function, and there's usually a corresponding implemented function that starts with PyObject, like PyObject call function or PyObject getAdder. But this might get you going in the right direction. PyObject getAdder is always called when you do that dotted lookup. That's what's always called. So maybe he did something to overload that. And you might be kind of smart, and you might say, well, overriding or overloading C functions. So how do you do that? Well, you might have heard of something like that using a technique called LD preload. And this is something that it's been around for a very long time. I don't know if it's POSIX or if it's Linux specific, but it's definitely something that is available on the machine where I wrote this. And one of the canonical examples for LD preload is overriding malloc, this memory allocation call that you use in C. And this is just a malloc call, and all it does is it prints out what you're trying to malloc and the return value every time you call malloc. And this is pretty straightforward, pretty boilerplate. If you Google for LD preload, you'll see some example that looks like this. And then on Linux, you can run a command like ls with this malloc call. And instead of calling the memory allocation that it would use internally, it calls the function that you defined, and it prints out all this junk to the screen. And you might say, well, maybe that's how he did it. Maybe he used LD preload. But that doesn't make sense, because if you look at the symbols, if you use a program called nm to look at the exported symbols for the Python executable that you run, and you look at malloc, you'll see that it's listed like this. It's listed as dynamically linked from your C standard library. And if you did the same thing on PyObjectGetAttr, you'd see it was not dynamically linked. It turns out PyObjectGetAttr, this function that implements this behavior in Python, is actually not dynamically linked. It's part of the executable. There's some bits on disk, and somewhere in there, there's some section of that, and that section of that is referred to as PyObjectGetAttr. But remember, C has no runtime, or it has a very small runtime, so it's just a bunch of assembly language functions with no live structure at all. And you can't use LD preload to do this at all. By the way, this is actually the process that I used in order to figure out how to write this myself. So I tried all of these things in that order. And so at one point, you'll just kind of get bored, and you'll say, OK, just let me look at the code. And you'll see what I did. What I did was I wrote a little function called hook. And what it does is it takes two function pointers, and it goes to one of the function pointers. It unprotects the memory page. It writes a trampoline, which means it goes into those assembly language instructions, and it writes new assembly language instructions that says, don't call this function, jump all the way over here. And there was actually some sophistication that was involved there, because you're limited by how you can do these kind of jumps in assembly. And it looks kind of like this. And what you can do with this is you can implement did you mean by going into the live running Python interpreter and screwing around with the actual code that was compiled in that yourself. One thing that I like about this example is that this is the last example I do before rehab. So the reason I say this is I started in Python trying to figure out how far can you take Python? What can you do with Python? And so I played with monkey patching here or there, and we've probably seen a lot of examples even this weekend of neat things you can do with monkey patching. I wasn't satisfied. I needed more. So I wanted to patch Python even deeper, and I found some other ways to patch Python even deeper. Last year I gave a talk about how you can embed Python interpreters within themselves, and I showed a Python 1 embedded into a Python 2 embedded into a Python 3. But even that didn't satisfy me, so I wanted to go even deeper. And this is just about the deepest you can possibly go, where you can live patch a live running Python interpreter. Actually, fairly reliably, it works on OS X and Linux, but it doesn't work on Windows, of course. But it works on OS X and Linux. Windows does a lot of memory protection, doesn't let you do that. But it works on OS X and it works on Linux. And you can essentially add any random customized feature. So any behavior that you want to add to Python that somebody will say, well, you need to do an interpreter patch. No, just use the did you mean mechanism, and you can patch it in there. Should you do that? Absolutely not. It's an absolute horrible idea, but you can. You can. And it turns out there's some really interesting things that you have to do in order to make this work. Like the reason getattr didn't change its ID is that you can go into the built-in module and you can swap out not the getattr function that the programmer sees, but the one that gets called behind the scenes. You can see that in a Python module, there's always this layer where you have some objects that are presented to the user, and it calls some C function in the background. Well, just swap out the C function while keeping the piece that's visible to the Python user the same. And you have to do some other neat and horrible things, like inside your hooked PyObjectGetAttr, it calls getattr itself, so you have to copy a little bit of code around to make it work. But I thought this was a neat example. This is one of the worst things I've ever done in Python. Now, one thing that you might say is this a generalizable technique? Can you randomly patch any possible interpreter in this fashion? And one thing that you could say is a limitation is that in Python, the standard Python that we use is written in C. And so being written in C, you can do things like get handles on the functions that are external for the Python interpreter, and you can do things like write to pointers and stuff like that. And in a language like Java, you can't really write to pointers. You can't You don't have a concept of pointers. And when I realized that, I was a little bit disappointed. But then I realized that on Linux, there's this proc file system. And the proc file system allows you to see the pieces of memory that you're using. It was something that was added to Linux in order to make it a little bit easier to understand what was paged into memory and what memory sections were in use, in terms of virtual memory at least. And there's this proc self maps, and this is all the things which this IPython, or this Project Jupyter, this IPython notebook has running. You can see all the memory sections. You can see the permissions and the ranges and kind of what's paged into there. And you can also see there's a file called proc self mem. When I saw this, I thought it was kind of interesting, because proc self mem is a file on disk that represents the virtual memory space of the current running process. And it's marked as read-write. So the permissions mean you can write to it and you can read from it. But if you look at the individual sections are marked read, write, execute, because there's some protection. You don't want to be able to write over pages that contain code, except that doesn't seem to exist there. And if you go a little bit deeper, you'll see, well, how is this implemented in Linux? And if you go into Linux source code, which any of us can download, and you grep, my strategy is you just grep for things. So I grepped for mem, and I found, well, this is how the mem object is implemented via proc mem operations. And if I go a little bit deeper and I look at proc mem operations, I can see, well, there's some function pointers here. And if I look at one of those function pointers, I can see it calls memrw. And if I look at memrw, I can see right here, you can basically read and write. The unprotect, protect calls in Linux are totally meaningless. If you want to write to memory, write via proc self mem, nothing will stop you. Absolutely nothing will stop you. If it's marked as read-only, who cares? Write through proc self mem, because it doesn't check the individual permission bits there, which means you could potentially generalize this technique to any interpreter. You could have, as long as you have some interpreter that has the ability to open a file and write to a file, it can self-modify its own assembly, which I thought was kind of cool. So I told you I'd answer a question for you. And the question is, who cares? And I think it's a very legitimate question. Like, who really cares? What's the point? And I can tell you kind of some of the reasons why I did this. One of them is self-edification. This was the result of a couple of years of journey of learning about Python and learning about C and learning about assembly. Who thought they'd see assembly in the keynote today? I'll go back and I'll cover it even in more depth if you want. But you learn a lot about this. It was also some practical training. Some of the debugging strategies that were necessary to actually make this work are very practical. I'm a whiz at using GDB now. I'm a whiz at using debuggers built into Python. If you have some process on your system that crashes, I can usually figure out where the bug is very quickly. Some practical training. While the actual use case was ridiculous, the skills that were developed in the process of that were helpful. It was fun, but some of us have different ideas of fun than others, and I'm sure you can kind of guess what my idea of fun might be. And I hope that some of you have a similar idea. I know that some of you do. I mean, otherwise you wouldn't be here on a weekend. And there's some enlightenment to it as well. When I've shown this off to other people, I talked about how this can help us with our so-called mental models. And one thing that people learning Python are encouraged to focus on is building the right mental models about Python. How do I think about Python correctly? Especially if you come from another language like C or C++, which may have given you mental models that don't map that cleanly to Python. Some people say that there are these false cognates so that you might see things in Python that are similar to things you'd see in other languages. And if you have the wrong mental model, it'll encourage you to write code in a non-Pythonic or a non-fluent fashion. And the way that I talked about this was, I kind of see that this topic can be very intimidating to a lot of people, especially once you hit the C layer, and definitely once you hit the assembly layer. But one thing that I really liked about this example was it took me a long time to do this. It took me off and on. The bulk of coding took me only a couple of hours, but actually coming up with the idea and learning enough to do this took me long. It took me up to, my career in programming up to the point where I did it. And one thing that I thought was, if you want to strain some analogies, you might think of learning a programming language like learning a human language. And learning a programming language like Python is actually kind of similar to learning something like Spanish. If you're interested in learning, there are a lot of resources. You're surrounded by people who speak that language. If you really want to learn to speak Spanish, you want to use it every day, and you want to be good at speaking Spanish, that's possible. And it's something that many people do every day here in Texas. And it's something that, somebody says, can you understand enough Spanish to hold a simple conversation? That might be something that's expected of you if you're, in certain parts of Texas, right? Learning something like C might be like learning Chinese. It's a little bit harder. You might have to get specialized books or go to specialized schools. You might have to find people who already speak the language because you may not be surrounded by people who speak the language. Learning something like assembly, maybe like learning a language like Tamil, which you have to really try kind of hard to find a book. And if you look at books, you'll see all the books are written 50 years ago, and it's very difficult to find people to converse with, and it's difficult to find teachers. Or if you want to go with a romance analogy, you might say learning Python is like learning Spanish, but learning C is like learning Portuguese. It's a little bit harder to find teachers, but there still are a lot of people who have to interact with that language day to day. But learning assembly is like learning Latin in that, it's a substrate for everything, but for the most part, outside of a couple of prayers and a couple of legal phrases and a couple of medical phrases, nobody really uses it that much anymore. So people can recognize what it means, but nobody actually puts the effort, unless they're the Pope, I guess, in learning it fluently. But the point here is that all of what I've shown you so far is something that's really within your grasp. It's something that anybody can do. Learning, if you look at the actual core of Did You Mean, despite how ridiculous it is, despite how provocative it is, literally the code there was measured in bytes. There's literally 6 bytes of code you have to know, and if you know those 6 bytes of code, it all kind of comes together. And anybody in the audience, if you're interested in that, it's possible to learn that, and it's possible to take your self-education and programming to that level. It may require that you find resources, and I think that an event like PyTexas and the people here are some of the resources that you might have available. So given the resources, given the motivation, it's possible. But I wanted to answer a more fundamental question for you. One thing I did want to note was that fundamentally I feel like computers learning anything related to computers, I feel shouldn't really present that much of a difficulty to us, because the good news is that humans build computers, and unlike things like the physical laws of the universe, upon which there is an enormous amount of debate whether those were built or not, computers had to be built to be understood by humans, so all of this stuff has to be understandable by somebody. It just might be very tedious or very boring. But I wanted to answer the core question for you. And the core question is, what does it matter? Does code matter? Does any of this stuff really matter at all? And I'll tell you my answer to this is, I'm not unbiased. Clearly, I know quite a bit about Python, and so I'm going to tell you, well, knowing a lot about Python matters. Why? Because I'm here to pitch you. But I'm going to be honest, I'm not going to pitch you. I'm not going to tell you it matters because I'm good at it. Because frankly, you could have a keynote next year with somebody who doesn't care about any of this stuff, and maybe doesn't focus on it, and maybe isn't good at it, and they'll say, well, code doesn't really matter. And that's not giving you anything very interesting or very meaningful. So I'll relate this to an experience I had a while back. I was once interviewing a candidate for a job, and the job did not require you to know a lot of Python. It required you to be interested in working in that particular field, interested in working in finance, and have a good working attitude. But one thing that we did when we interviewed people who had Python on their resume was we'd ask them, from 1 to 10, how would you rate yourself on Python? And the reason for that wasn't that we needed 9s or 10s, but that we needed to figure out what the right question was just to get as much information as we could. We had a candidate come in once, and we said, how would you rate yourself, 1 to 10 in Python? And his response was, come at me, bro. And that's not a good way to start an interview. So I said, okay. So I went up to the board and I wrote these 3 lines, and I said, what is this? And if you know Python very well, then you'll look at that and you'll figure out what it is in some period of time. And he was like, I don't know. And I said, okay, is this an old style class or a new style class? I don't know. What's the difference between old style classes and new style classes? I don't know. What are underscore methods in Python? I don't know. What's a meta class? I don't know. Didn't know anything. But yet he self-rated himself as a 10. And then it was very difficult, because what kind of questions can you ask if you're meeting that kind of distance? However, I happened to ask him an interview question that we had prepared that had a small mathematical part. And he latched onto that mathematical part like nobody's business. And he answered it better than any other candidate before. And we asked him, well, you're clearly very, very good at math, but your Python skill that you have on your resume right next to math is not quite there. Let's chat about that. And what he said was, well, coding doesn't really matter. Programming doesn't matter. The most important thing is math. And at that point, I realized this is really surprising, but the most important thing in the world for most people happens to be exactly what they're good at. It's a coincidence. Who could have guessed it, right? So I'm going to try to avoid answering that question in that fashion, right? Because I could be very biased, and I could say what's most important was what I'm good at. And I feel like a lot of advice and a lot of commentary about whether code matters that you read on the internet is exactly in that fashion. If you read, Hacker News or any of these postings from Silicon Valley, you'll see people who they're very good at one thing, and that thing might not be programming, and coincidentally, programming is not that important. So you see this a lot in the data science community as well, because data scientists will say, well, programming is not that important. They don't care about programming. Data scientists do not care about code. They see it as a means to the end to do what they think is important, which is data science. And then you have a lot of people who are data engineers or programmers, and they look at data science and say, well, the work that you're doing is just import this from scikit-learn, import that from pandas. I could just look it up in a book. What's important is the structure of the application. The programming is most important. And you can see there's a lot of bias here and a lot of disdain. So I had a lot of difficulty trying to figure out what the answer to this question was for you in such a fashion as could be presented in an hour worth of time. Clearly, code can matter. We can easily construct some situation in which writing the most elegant code or the most perfect code or solving some ridiculously preposterous problem like did you mean, clearly something like that can matter. But that's not really a very meaningful, that's kind of a lame answer to the question. It's not very meaningful. And I could go and say code never matters. I could say code only matters. Or I could give you the lamest answer, which would be code sometimes matters and sometimes it doesn't. But that's not conveying anything that you probably don't already know. So the best I could do to answer this question in a fashion that you might not already have come across is this. And it's very important, I think, in these kind of analyses to look for something that is both meaningful and correct. And they're not always joint. And one example that I like, that we don't have time to get into, but I like to say is if you ask somebody who's an intermediate Python user, and you ask somebody who's an expert Python user, what is a decorator? One of them will probably tell you an incorrect answer, and probably some of you who are thinking right now what you're thinking in your head, probably an incorrect answer, but it's very meaningful. And if you ask the really expert user, who might at the time want to self-indulge and tell you exactly as strictly correct as possible, they can tell you very strictly, very correctly what it is, which is it's a little squiggly. That's more or less about it. But it's not a very meaningful answer. It doesn't really give you anything meaningful there, right? Honestly, over lunch, I'll tell you what a decorator is if you're interested. But I want to try and figure out an answer that could be both meaningful and correct. So the best I could do is to try and constrain this analysis, to constrain this answer for you, which is, I think for most of us, the code that we experience is a constituent in some kind of business process. Clearly, there are some of us that code for fun, that do it as something, as an artistic expression, but many of us are trying to accomplish some goal, and usually that goal has to involve something that you do 9 to 5. It involves your job. It means that somebody's paying you money, or maybe that, or maybe if you're lucky, like some of us, that. By the way, if you need any Python or finance or data science, come talk to me. You get money for code, right? So there's that component to it. So the code that we experience is the consequence of someone's telling us there's something that's paying our checks that has to be done. And there's some artifact. And the task that's actually paying our bills, such as somebody picking up a phone and making a trade, or somebody clicking on a like on Facebook, or somebody watching a movie on Netflix, or somebody purchasing a device on Amazon, or purchasing something on Amazon. There's some task that has some component to it that can be automated. And again, this is kind of a wishy-washy thing, because what does it mean to be automated? Bear in mind, we're just trying to constrain the analysis as much as possible to get a good answer out of this. This component that can be automated can probably be done either faster or better by a computer than a human being. And there's actually a little bit of meaning we can tease out from this, which is we often see processes which are unnecessarily automated, where somebody has made a decision to take something that maybe took a human being an hour to do and to replace the entire hour of their time with some automated process that ends up being very fragile. And it would have been better for them to take out 30 minutes of the human's time and then let the human adjudicate or handle all the corner cases themselves. We've often seen automation processes that handle all the corner cases, and they rarely work. They collapse from the complexity. And that in many cases, there may be components to this task that are easy to automate and components that should still be left in human control. I mean, come on, who's been to, a flight and the computer's down and they're completely helpless? There's clearly some tasks which the computer's good at automating, but we still need to have some human control. Given that, in order for this task to be amenable to automation, and if we think of automation in the simplest sense of, physical, mechanical automation, in order for it to be amenable to that, it has to have some structure. In order to do some physical automation, like a bottling factory, it has to have some fixed, rigid structure. The bottles need to be moving in a particular fashion. They need to be going down the assembly line. There need to be tolerances around that. And in the world of programming, this structure is often artificial. And this artificial structure we might call a model. And we may often not even be able to see what that artificial structure is. We may not even be able to see what that model is. We might just assume it. For example, if any of you here had to model some signal that's continuous, you probably all use IEEE 754 floating point, up until the point when you realize that it's a very useful approximation of actual real numbers. And in many cases, especially cases related to rounding, it can break on you in some very horrific fashion. Similarly, if you had to do that to manage sums of money, you could realize that as the sums of money get very, very large or very, very small, you can't exactly represent them. And that might be a problem. But we still use IEEE 754. We still use floating point numbers. We still use machine floating point because it's a very efficient and mostly correct and pretty useful approximation of the actual problem. Typically, though, this model is something that we express in terms of the components, the moving parts of how the system works. And we express it in some terms of computing fundamentals, things like modules and functions, or producers and consumers, queues and stacks, trees, traversals, things like that. And then we take that code, we take that model, and we encode it in a programming language. We kind of spell it out. We write it out in written form in a programming language. With this very narrow analysis, we can then see, and we can actually get an answer to this question, does code matter? And the answer is yes, code can be made to matter. If we constrain the top parts of this funnel, if we say, given a fixed problem we're trying to solve, and a fixed model for how we're trying to solve it, we have producers and consumers, we have functions and this and that, then you can look at the code and you can say, well, this code's better than that code based on some very strict analysis. You can also take that analysis one level up, and you can say, well, sometimes the model is wrong. And we see this happen all the time. For example, if any of you ever dabble in game programming, you might start by writing your game in a way that seems intuitive to you, with game objects and things like that. And then at some point, you hit a performance bottleneck, and you realize, well, the actual way to make this performant is I have to represent everything as abstract matrix multiplications and throw it on the GPU and call it a day. And there, you've taken a model that was intuitive, that worked very simply, and you've revisited the model. And of course, necessarily, you had to revisit the code. Given that, I wanted to show you one example of how the code doesn't matter, and some cases where the code doesn't matter. And this is something that came up last night. I really wanted to include this because it's a question that came up from Kevin, one of your illustrious PyTexas chairs last night. And he wrote in a decorator called thisify. And what it does is it means that you can create a function and it takes itself as this parameter, just like we know that in Python we have this explicit self, so that methods in a class take a self parameter. You wanted to have a function take its own state as the first parameter of this. And he asked, well, where do you think this could be useful? And I used this exact analysis to answer this for him. Well, I said, we've ignored the business problem. We've just presumed that there's one exists, that we have some reason for writing this. And we've ignored the model. We have this thing that's a manifestation of this model in this particular amount of code. And we're trying to figure out if we swap out the code with the model fixed, does it matter? And the answer is no, in this case it doesn't. In fact, what this really is the exact same thing as, well, this is first a use case of it. So he wanted to set some state on some function. So you can see you call this function 3 times, and every time it gives you a different result because it has some internal state, and it can manage the internal state with this because it can set attributes on itself. And if you're smart, you might look at that and say, well, that's exactly the same thing as writing an object with an underscore call. And here you can see the code doesn't matter. Literally, we have the exact same model implemented in 2 ways where the code doesn't matter, and where the code is only very slightly different, and probably in most cases, either 2 of these are more or less identical. And if you've seen any of my many generator talks, you might even be smart enough to say, this is exactly equivalent to just a generator, because a generator is just a function that has some state. It's a coroutine, right? And so you can implement it in that fashion. But we can see that given this analysis, you have some business process, some computational model, and the code is the expression of that model. If you fix the model, sometimes the code doesn't matter. Now, I can tell you that that's not as, I know it hasn't warmed the cockles of your hearts. I'm really sorry I couldn't tell you definitively that code does or doesn't matter, but the best I can give you is a framework. And this is something that really caused me quite a bit of consternation, but the best I can give you is a framework for analyzing what code is and where code might matter. And it's an argument that I think comes up all the time. You write a little bit of code, and somebody says, well, that code sucks, and they rewrite it. But you look at that and you say, well, this is accomplishing the exact same thing. You still have producers and consumers. You still have modules. You still have indirection. You still have abstraction in the exact same places. You've just spelled it a little bit differently. And in those cases, the code doesn't matter. But in other cases, the code may be the only possible implementation, the only possible representation of that fixed model. How many ways can you represent matrix multiplication than in the ways that we do in Julia, NumPy, and R, and Pandas? They're all about the same representation. In those cases, it does matter. So that's my best attempt at answering that question, and also taking you down a little bit of the rabbit hole of what you can do with Python. This was Don't Use This Keynote. I'll tell you, if you're going to clap because I've actually ended exactly on time. So I really hope you enjoy this event. I've had an amazing time so far. I'll be around all weekend. If you want to see something cool, come up and talk to me. If you want to give me money, I'll leave my pockets open. It's PyTexas. I'm James Powell. Also, follow me on Twitter. Thank you so much.